Now in this bootloader part we'll see the some more mm, uh, documented, and then we'll jump into the after this theory we'll jump into the code development. Okay, so basically the bootloader code placement in Flash, we will take two sector for bootloader codes. So SD bootloader will contain in this 32 KB. Okay, but our bootloader, our custom bootloader, we have seen that where is the bootloader stay and how it will communicate in our earlier video. Now our custom bootloader will give sector 0 and sector 1. So we know that our every sector is 16 KB. So total 32 KB will take for bootloader code placement. And after that, from sector 2 to sector 7, our application, uh, whatever user application, that application code content in these sections. Okay, the bootloader sections in this part, and application part will contain in this part. So how actually in the programming that understand that bootloader will contain and this to this boundary, and after this boundary code will start from this boundary to rest of boundary, that we have to set in our coding also. So we'll see how to set this also. So let's see how actually it is done. Okay, then it will be more easy to understand. Let's jump into the code. If you go into the code, there is basically the called the, so as you know actually that the when we place the code, the first placement is vector table, and above the vector table our dot text and data raw constant data. In this way, dot bss dot data section, everything contained in this way. So the first, if we say that suppose your memory segment is like this, flash memory. Okay, and your vector table, bootloader vector table content here, and bootloader take two segment. Then you have to change the setting in this way that your application vector table content here. Okay, so if you set the vector table offset, instead of offset 0 0, we have to set this 32 KB offset for your applications. Then your application code will understand that okay, I have the memory from this location. You don't know about these locations. When you take the vector table offset in this value. Okay, so if we jump into the code, then how where we'll see that there where basically it is mentioned that vector table offsets. So if we go to the bootloader coding, you will see that vector table is nothing is changes in this vector table. Vector table offset is basically not defined. Okay, it is not define the so default value is 0 0, vector table offset 0 0. Okay, but if you go to the user applications, then here basically I've mentioned that vector table offset not 0 0, it is this value. So 8000 is basically the 32 KB. Okay, so I have mentioned that vector table offset is not 0 0. This should be this location. So this part is basically the active, and this vector table offset actually used in combination to place the code. Okay, so flash will start for application these locations offset. Uh, Whatever the actual address, this offset will added with this uh, actual absolute address, and it get the actual locations. Okay, then we also create the communications with the host and bootloader so that we can communicate with the bootloader. You will send some command and the bootloader will reply based on this command. So there will be a host will be, suppose some application will run in your computer, some user interface where from where you will send the command, and the MCU, that is your microcontroller where bootloader code is placed, and that bootloader will accept the command, then decode it, and if the command is valid, then it will send ACK. If it is invalid, then it will send NACK, and the length followed by 2 byte. So it will send ACK, and also the length will reply based on this command packet. And also if any data user or host want to read along with the length, he also reply the following length byte data. So how to communicate with the host and controller we'll see also. So now what is the command packet? How will uh, arrange the command and also use in our bootloader code that it can understand properly. So if we see the command format, that suppose there are multiple command. Okay, so suppose the command name is bootloader get version. You want to read the which version, bootloader version currently working in your system, so you can read the bootloader version. So there is basically a for this format should follow. Okay, every command mm, minimum this format should follow, maybe more than that also, we'll see one by one. So first 1 byte, there is basically 6 byte total, command is 6 bytes. So okay, that the first byte is the length information. First byte will carry the length information, and the second byte carry the command code. So for get bootloader version, this is the command code. So to then the last 4 byte is CRC. So this 2 byte compute as CRC, and that's also sent. Okay, so receiver match that data is corrupted or not, whatever the command is come, that is valid command, and also not corrupted, that basically decided by the CRC. So bootloader command will be total byte of bootloader packet is 6, and the length to follow field will contain the 5 value. So after length there will be 5 value. Okay. So bootloader version reply after sending this command. Okay, what bootloader will reply? Bootloader will reply bootloader version number. So that is 1 byte value will reply with in 1 byte, which will be the bootloader versions. Next, if we talk about the next command, that is get bootloader get help. So if you want to take some help with bootloader, then this command also available, which also follow the same format. First is length, second is command, and the command is this. So every command has a unique value within 1 byte, and then the CRC and the what are the supported command available in your bootloader, that code will reply when you send this command. Okay, that I am supported this command. If you send this command, then I will reply according to that. So that you can also read by sending the bootloader get help. After that, command name is the bootloader get CID. Okay, so chip identification number you can also get. So if you send, that's also follow the same format, that first length and second is command, and the command is this, and then CRC. So this total is 6 bytes, and after the length there will be 5 bytes. And what basically it will reply? It will reply the chip identification number. This is basically reply will be 2 bytes. Bootloader reply 2 bytes. Okay, and the first MSB byte chip ID, and LSB byte also chip ID. Okay, so within chip ID basically in the 2 bytes. Then the next command is bootloader get RDP status. So read protection status, you can also get that there is any am I able to read or not. So read protection status also you can get, that is also the follow the same format, and RDP read protection status basically in 1 byte. Bootloader reply in 1 byte that are you able to read or not. So basically, are you able to read the code or not? Okay, so read write protection, we know that in our controller ST control there is also read write protection available. So that status also you can get using this command. Second is bootloader go to address. If you want to go a particular address in the bootloader, then you can also go to this address by uh, this command. Okay, so if you use this command, then you can go particular address, and this is the command, internal command format, that is uh, length, and second is the command code. Then actually you have to provide the memory address information, which memory you want to go, that information you have to provide in, and that we know that memory information basically the 4 bytes, so that is 4 byte length. Okay, so after command you have to also provide the address, which address you want to go, and then CRC, so that is basically the 10 byte packet total. Okay, 4 plus 4 and 1 2, so total 10 bytes, and after the length there will be 9 bytes. So based on the memory address, it will jump to this address, and bootloader also reply in 1 byte that I have successfully jumped or not. Okay, that is status also reply. Next is command is the flash erase. If you want to erase the flash, then that is also possible using this command. So that is basically taking the 8 byte packet length, and first contain the length information, that this length information basically, after the length information, this 1 byte, how many bytes are coming. So their total is 8 byte, but after the length information there are 7 byte data. So your code will understand that I have to read this 7 byte data till the 7 byte data. Okay, so first is the command, and the command basically this 0x56, and you have to see the sector number, which sector number you want to uh, erase, from which sector number you want to erase, that you have to tell, that sector number 0 or sector number 1 or sector number. The starting sector number you have to mention here. So whichever number you will put, from this sector it will start erasing, and then you have to mention also that how many sector, from the starting sector how many sector you want. Suppose you have to put that sector 2. Okay, in this location you have put that 2 number sector, then you have to put that after 2 sectors, from sector 2 how many remaining sector you want to erase. So suppose you have to put again 2. Okay, then it will erase 2 and 3. If you put 3 here, then it will also erase 4, because 1 2 and 3, so it will erase from 2 to 3 sectors. If you put 2, so in this way it is the actually the starting sector, and from starting how many sector you will want to erase, that is mentioned here, and then CRC, and after that it will reply only the status, that it is able to erase successfully or not, that it status also sent. The next basically the bootloader memory write. So suppose you want to write data using this bootloader, particular memory address you want to write your data, then this command format you have to follow. First is the len, second is the command code. So that is basically from this command code you understand that whatever the next information will come, that is will be the that from this command code he understand that what action I have to perform in the following using this following data. Okay, so the base memory address you have to provide after that. So from which memory address you start writing this payload. So then you have to also mention the payload length, that how many data you want to write from this memory address, and then you have to provide the payload. So first the payload length, then the payload, that means the data, then you have to provide the CRC. So whatever the length of this payload, the but please keep in mind that this is 1 byte, sorry, this is 1 byte. So the maximum payload here contain only how many? 255 bytes. Okay, 255 bytes. But you have to also keep in mind that this length information is 1 byte. So although this payload can contain maximum value is 255 byte length, but this length information also inform that how many data coming in the next command. So if we sum up this, then the value will be this. Then here x maximum will be 255 minus 11, so 244. Okay, so this length maximum value means here maximum 244 bytes will contain. 244 bytes will contain. Then it's will be 244 is this information, we can neglect this length, so it will if we add this length, then it will be 245. So 245 can contain here. So whatever payload you will give, if it is able to the payload length and payload byte writes, then if it is write successfully, then it is also reply with the successfully status byte. 1 byte will give the it is able to successfully write or not. Then the if you want to read the memory, then you have to follow this. Only you have to provide the memory address, which memory address you want to read, and also the how many bytes you want to read. That length information you have also put here. Okay, number of bytes, how many bytes you want to read, that you have to also put here. So that is 1 byte, so you can read at a time 255 bytes. And then the it will give in status in first is status, and the whatever the number of byte you want to read, that bytes also you will get it reply. So in this way our bootloader command will, there is also the sector status. So if you want to get the status uh, of sector, so that will also you can read. And also the read write protection, if you want to read, then you can also read the read write protection. So uh, if you want to write that, this should be read write protected. So you can also send the protection mode here. If you write 1, then it will be protected. If you write 0, then it will be non-protection mode. So protection mode basically no protection. So there is two type of protection, only write protection or read write protection. So it will also set the, and there is actually you can also individual sector, you can also able to uh, read write protection apply, you can able to apply read write protection individual sectors also. Sector wise you can also apply the read write protection, and then it will send the status. Now you disable the read write protection. Suppose you have applied the read write protection, now you want to resume in default mode or disable the active protection in all sector, then you can also do in this command. Okay. Now we'll jump into this our bootloader flowchart, how actually your bootloader code will run, how you can able to communicate and do the coding parts. So once you reset the MCU or power on the MCU, it initialize the HAL layer, then the required GPIO, then UART, then CRC engine, then clock. After that, it will see that user button is pressed or not. So after resetting, if you want to do something in bootloader code, then you have to press the switch. If the button is pressed, then bootloader UART read data. So if the button is pressed, then bootloader what it will do, it will reading the UART data. But if your code see that button is not pressed, then it will jump into the user application. So from the bootloader coding part, it will jump to the user applications if the button is not pressed. So if you want to use the bootloader communication for this command setup, then you have to reset the board and also press the user. Otherwise, if the bootloader code jump into the user application, then it will start executing the user application. It will not contain bootloader coding. So suppose you have press the reset and press the switch, then it will jump into the bootloader. Then the below part we'll see in next slide. So it will, that is basically the bootloader. You want read data. After that it will start polling your data. So it is continuously in polling mode. So when it's get length information, the according to command packet, first data will be length information. So when he receive the length, if length receive, then it will go in this way, or if nothing is coming, it will only waiting in polling for reading the data. Until any data is coming, it will continuously reading through UART. Once the length information received, it will go in this way and read the length number of bytes. So in the length information, he can understand the how many data will come from this length byte. When he understand that this number of bytes will come, then it's decode the command from read the first. After the length, he read the first command bytes. So decode the command, and based on the command he understand that which tasks I have to handle. Then it will go to the handler that corresponding command code, and then it will finish the handle command. Okay, it will finish the handle whatever command come according to this. It will handle this and provide the status also, and then again it will jump into the bootloader reading mode. Okay, so if you also want to jump into from bootloader, suppose you have pressed the button and it will continuously pulling in bootloader mode. But if you want to switch to application mode, then again you have to reset and don't press the switch. So how it is actually handling? So in handle, it will first read that CRC, check the CRC. If CRC match, CRC is good, then it will send a acknowledgement, then obtain the reply, whatever the reply is required, that reply it will obtain, and send the reply to handle code, and again start you are reading data for next, waiting for next command. But if CRC does not match, then it will send NAC and finish the handle command. It will not executing, but it will actually finishing, and again jump into the reading, jump for reading the UART data for waiting for next command. Okay, so in our next part, that will be very lengthy, so in our next part we'll discuss about the coding parts. Okay, how we have actually implement this everything and whatever I have mentioned in the